Astronomers think there are 10 million or so black holes in our galaxy. If one of them strayed into our neighborhood, it could rip our planet to pieces. Earthbound telescopes may not even detect it. Humans would only know it was approaching when its immense gravity triggers huge floods and earthquakes. As it plunges into our atmosphere, the black hole acts like a vacuum cleaner, sucking with a force over 1,500 times Earth's gravity. Then it begins to distort the shape of the whole planet. Earth's surface stretches and tears apart. Finally, the hole hits and flies straight on in, heating and vaporizing matter as it goes. It starts to orbit the Earth, inside the planet itself, all the time devouring everything in its path. Gradually, the orbit slows. The black hole spirals down into the Earth's core. Eventually, it eats the entire planet. All that's left is the black hole itself. It's a devastating end for planet Earth. But fortunately for us, it's unlikely ever to happen. So, if black holes don't work, time for a new approach. One surefire way to destroy the Earth is to change its distance from the Sun. Move the planet closer and it bakes. Move it out and we freeze, sending us into another ice age. Scientists have recently begun to realize that moving a whole planet might actually be possible. In fact, we use the same principle to slingshot space probes round the solar system. Planet Earth could be just a few well-placed flybys away from a fiery death. What would it take to incinerate an entire planet? Answer: a nuclear furnace nearly 1 million miles across. It sounds crazy, but the truth is this will happen. It's just a matter of time.
As the sun gets older and older, it's going to actually get brighter and brighter. And within about 2 billion years, the Earth will be in an uninhabitable zone. It'll be like Venus. There'll be a runaway greenhouse effect. All the water on Earth will be destroyed, and the surface temperature will be about 1,000 degrees.
Eventually, the sun will swell and scorch the Earth, unless we somehow move the Earth away from the sun to save it.
Alternatively, if you were sufficiently evil, I suppose, you could imagine doing exactly the opposite. Harnessing sufficiently large objects to transfer gravitational energy to kick the Earth's orbit closer to the sun.
Easy to say, not so easy to do. The Earth weighs in at 6 trillion tons. Pushing something that big is quite a challenge. But there is a way. It's called gravity assist. Space probe engineers use gravity assists all the time. Take Saturn's Cassini-Huygens probe. It's the size of a school bus, one of the biggest probes ever built. To build up enough speed to fling the probe out to Saturn, it had to swing by Venus twice and Earth once. Each flyby stole energy from the planet and added it to the probe. The probe got a lot faster by altering the planet's course just a little.
The name of the game here is energy, orbital energy. There's energy in the Earth's motion. So as the Earth's orbiting the sun, if we can steal that energy away, it'll fall in toward the sun. And we can do that using an asteroid. We take a rock about a mile or two across, and we move it so that it just passes the Earth the right way, and it'll steal energy away from the Earth. The asteroid will go flying off, and the Earth will move in toward the sun. But we shouldn't just waste the asteroid when we can recycle it. If we're clever, we can take the asteroid and have it go toward the planet Jupiter. And then if we pass Jupiter in just the right way, it'll take that extra energy it stole from the Earth, give it to Jupiter, and then fall back toward the Earth. And if we aim everything just right, we get a conveyor belt of energy. We steal it from the Earth, give it to Jupiter, and then come right back. And in fact, we can use hundreds or even thousands of asteroids this way, continuously stealing Earth's energy and dumping it toward Jupiter. And before you know it, the Earth is falling into a fiery plummet.
First, you need to catch an asteroid. It's as big as a mountain, and it's traveling around 10 miles a second. Next, you need to attach rockets and boost the asteroid onto the perfect course. Next, repeat, thousands and thousands of times. Very slowly, over thousands of years, the Earth will fall towards the sun. Right now, we're just over 90 million miles away. By 70 million, the Earth is a superheated desert like Venus. Then things start to get really bad.
As the Earth slowly spirals into the sun, a series of events unfolds which unfortunately spells doom for our planet. As the Earth approaches the sun, the atmosphere heats up and blows off, and the oceans boil, basically turning the Earth into a giant comet. But there's worse to come. As the Earth gets closer to the sun's gravity pulls on the near side of the Earth more than it pulls on the far side, and the Earth stretches like putty. At some point, it gets close enough to the sun that the sun's gravity can overwhelm the Earth's gravity, and it shatters, pulverizes our planet.
The Earth is dead, but its ghost could remain, a faint ring of material around the sun. Peter Schultz, planetary impact geologist.
If the Earth or any object gets too close to another object like the sun, eventually the tides will rip it apart. As that happens, it would simply be broken into many small pieces that would then encircle the sun as if it were a ring.
The sun would resemble Saturn, with its own faint ring of rocks and dust. A fiery death and a ghostly remnant. If you want to destroy a planet, this could be the way to go. Maneuvering billion-ton chunks of rock with pinpoint precision at hundreds of miles a minute is quite a stretch. Not to mention the amount of time it would take to capture enough asteroids. We've tried to crush it and burn it. It's time for another plan. An antimatter bomb. Physicists have been searching for over a century for a theory that unites our understanding of the large-scale universe, planets, galaxies, and stars, with what we know of the subatomic world, electrons, protons, and quarks. Their theories are bringing to light some pretty destructive phenomena. One of them could be a world killer. Antimatter. Theorized in the 1920s, detected in the 30s. Now we can create antimatter in modern particle colliders. And the base ingredient for the biggest explosion possible.